Okay, Algebra 1 students, today we're going to do Unit 15-2. We're actually going to take 2 days to do the rest of 15-2, so we are slowing it down a bit from what we would normally do in class, so this is only really half of it. And we're going to try to answer these 3 questions. I'm going to answer 2 of them, and then this question, you're going to you probably figured it out from last week's homework, or you'll figure it out from tonight's homework, okay? But the 2 questions I'm going to focus on, the number 1 question, what we need to learn today is, how do we find the vertex and the AOS, the axis symmetry equation, when we use just the quadratic formula? In other words, no factoring. And no Desmos, of course. And the second one that we're going to do is what happens, we're going to do one example on this, what happens to the quadratic function when the graph does not touch the x-axis, right? So there's no x-intercepts. So the quadratic, the parabola is either above or below the x-axis for all of its range. So we're going to take a look at those 2, the 2 in blue. Let me put this one in blue. We're going to take a look at these 2. We're going to do the bottom one first, then we're going to do this one, and then you're going to figure this one out tonight for homework if you haven't already figured it out. It's not too hard to figure out. Okay, so as I said, let's do the first one first. This third one first. How do we find the vertex and the AOS when we use the quadratic formula? Okay. Now, what I'm going to do in both of these cases here is I'm going to first use Desmos, okay? And if you look, I found this through Desmos just by pointing to this vertex and the axis symmetry. The axis symmetry is this dotted vertical line that splits the parabola in half into 2 equal parts, right? Perfect symmetry. You could fold it over and it would line up perfectly, right? That's what that symmetry means. And there it is, right? So if you look at our graph here, it's 1, -6. 1, -6. And the AOS is always the x value here. X equals 1. Okay? I just stole that from Desmos. Nothing magical there. And that was for this parabola here. Example 1. Okay? And then for example 2, we did the same thing. We graphed example 2. It's not the same. It looks kind of the same, but it's not. In fact, I'm missing a negative sign here. So just fix, this will be fixed by the time you get this, but there should have been a negative here. Sorry about that. Actually, we'll use regular ink to do that. Otherwise, it wouldn't be facing down, right? So hopefully you would have caught that anyway. But anyway, there's a negative 2x squared minus 4x minus 2 here, okay? And then what we did for this one is the exact same thing. We put it in Desmos, okay? So we did it first using Desmos. We graphed it, and we found out that the vertex was -2, 2, and the axis symmetry is the equation of x equals -2, right? All vertical lines have x equals a number. And again, the green axis symmetry here, I know they vertically line up here, but they're 2 separate graphs. See, 0 is way over here, right? So you can see 0, 0 versus this 0, 0 here. So don't be fooled. This is to the left here. So it's at -2, 2. Right? -2, 2. And the axis symmetry is x equals -2. So we're gonna watch in the quadratic formula for where this 1 in this problem here, let me use yellow. So we're looking for where does this 1 and this 1 appear in the quadratic formula, or does it? And where does this -2 and this -2, where does that appear in this example here? Okay, so let's look at the first one. So I'm going to use the quadratic formula, and we're going to pretend we don't have Desmos here, right? So how would I do this if I don't have Desmos? Of course, we have Desmos to see what the pattern is. So identify A, B, and C, which I've already done for you. So this is A is 2, B is -4, C is -4. We're going to plug it into the quadratic formula. When you do your homework, you've had 2 times to redo last week's homework, right? Or 2 times to do the homework. So at this point, I don't want anyone not showing these steps, right? This work. That's what we went over last week. That's what I did when I did your corrections. And at this point, you're not going to get credit for the problems on the quiz if we don't see the work. Okay, so you need the steps that I'm going to do here. So you need to write x equals, first of all. Remember, we're going to be using this formula in this version. I know some of the first worksheet, we had some problems with that, right? But I fixed that since. So we're going to break it up into 2 things. We're going to get this piece first here, and then we're going to plus or minus this piece here. So we're going to write it as 2 separate pieces, okay? Okay, so x equals, right? And I'm just using the formula here, minus b. B is -4, so that's going to be a double negative right away, I can tell, right? Over 2a. Now a is 2, so that's going to be 2. Okay, plus or minus the square root, be as neat as you can, make the square root go all the way over. B squared, I like to use parentheses so I don't mess this up. B squared, there's B, minus 4 times A times C. Okay, there's C, all over divided by 2 times 2, again, 2A. Okay, very important to separate this into two separate ones, as you'll see in a second why it's so important. Okay, I'm just going to bring my work down here to simplify. So it equals, now this is double negative, so negative negative 4 is positive 4, divided by 4 is 1. Okay, 4 divided by 4 is 1. Plus or minus, that's going to break into two problems, right? So I'm going to do this. This is 16, and this is 32. Now this is positive because you have negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32, right? So I'm going to get the square root of 16 plus 32. There's no multiplication there, like some of you tried to do the other day. Oops, plus 32. So 4 times 4 is 16. Sorry, negative 4 times negative 4 is positive 16. Positive 16 times 2 is positive 32. So I did it two different ways. Comes out the same no matter what. Okay, divided by 4. Now this one's not divided by 4 because it reduced, right? This one's not divided by 4 because it reduced. So I get, I'm going to slide it over here to fit it. X equals, right, 1 plus or minus the square root of 48 over 4. Now we talked about how to do, so way up here, maybe we'll do square root of 48. Right, and we need to find the biggest perfect square that goes into 48, right? So I know 4 goes in, and if you think about 4, if you divide 4 into 48, right, I know 4 is a perfect square, right? You're going to get 12. But 12 also has a 4 in it, right? So we're thinking maybe something bigger goes in here, and certainly it does. It's 16, right? So remember, our perfect squares are 4, 9, 16, 25, and really, you know, for quiz purposes, anything above 36 here, I mean, you should know them all, 49, keep going. But you know, most likely it's going to be something like what we just did here, 16, and of course goes in there 3 times. If you do the long division, you'll see 16 goes in there 3 times. Okay, and of course the square root of 16 is 4. That's why we pick out perfect squares, so that happens. Okay, so really this is equal to 1 plus or minus 4 root 3 over 4, and then the 4's are going to reduce. The 4's are going to reduce because 4 divided by 4 is 1. So really we get 1 plus or minus the square root of 3. Okay, now what does that mean? That means x equals 1 plus the square root of 3, or x equals 1 minus the square root of 3. Okay, now here they are. These are the points that we're talking about, right? 1 plus the square root of 3 and 1 minus the square root of 3. Okay, the square root of 3 is about 1.7 roughly, right? So what they're saying is start at 1. Now watch what I do here. Watch my color coding and everything. Watch what I do. See, they're saying take 1, right? Start at 1. Start at 1. See it there? And go plus radical 3. That's 1.7 to the right, roughly 1.7. So start at 1 and go 1, not quite 2, but 1.7 to the right of it. See, 1.7 to the right. I'll even write that on here. I'll use green. Okay, so 1.7, and it's approximate. Radical 3 is not exact. It's 1.71 actually, but I'm just rounding it here a little bit, right? So it's telling you to go 1.7 to the right of this, x equals 1. And then over here, right, this one here is still 1, but they want you to go left, right? It wants you to go left. In other words, subtract. Let's grab the green pen, right? So this second, so there's 2 answers to the problem. There's their first answer, right? And there's the second answer. And those are the x values of the x-intercepts, right? We call these the zeros. They're called the zeros but they're also the x value of the x-intercept. That's what these are, x-intercepts, where the parabola hits the x-axis. So it says start at 1, go to the right 1.7, start at 1 and go to the left 1.7. So start at 1, here's 1, and go to the left. 1, almost 2, but not quite. So 1.7 to the left. Now, it's really negative 1.7 because I'm going left, but if I label it as a length here, it's 1.7. See, it's 1.7 to the right and 1.7 to the left. Okay? Now, we're going to do the same thing on this problem and see how different it is, okay? Okay, so for the second example, we did the same thing. We used Desmos here. We found the vertex already, so it's negative 2, 2. And the axis symmetry is x equals negative 2. Okay, remember the original one? It was 1. That was the x value and the axis symmetry. And here it's negative 2. Don't be fooled that these are vertically lined up, right? They're different graphs because here's 0, 0, and here's 0, 0, right? Sorry, here's 0, 0. So you can see this one's way to the left. That's why it's negative 2, where this one was positive 1. Okay? All right. So again, this 1, we're trying to find out where that 1 appeared in the answer here, and we're going to try to see where the 2, or the negative 2, excuse me, appears in this problem when we plug it into the quadratic formula. Okay? So there was a typo earlier, so you may have seen a number switch, but it's the same on your screen. So your screen has this correctly, right? So A is negative 1, B is negative 4 here. It's negative 1, negative 4. When there's no number there, there's a 1, of course. And C is negative 2. And there's no x there either, by the way, so that won't be there on your screen. So it's just minus x squared minus 4x minus 2. So C is negative 2. Okay? And that's what this graph is. So let's plug in the formula and see what happens. Okay, so it's x equals, of course. Remember, we're going to use this quadratic formula here. Remember, always use this form. We'll give you this form in the quiz, so you don't have to memorize it. It's in 2 parts. You always want it to be in 2 parts when you fill it in. So x equals negative b, b is negative 4, so negative negative 4 over 2a, right? Over 2, I've memorized the formula, of course, so I'm just reading off this formula here. That's what we're just filling in, right? 2a, and a is negative 1 here, okay? And then if you look back up here, plus or minus comes next. See the plus or minus, right? That's what we're going to do. So that's the first fraction, and then we're going to do plus or minus, meaning that there's 2 answers most likely, right? And then, of course, the big radical. So it's b squared minus 4ac. That's 3 negative numbers multiplied together, all over 2a again, which is 2 times negative 1. Okay? All right, so let's see what happens when we simplify this, right? We're going to get x equals. Now, this is negative negative 4. That's a positive 4. 2 times negative 1 is negative 2. Positive 4 divided by negative 2 is negative 2. And that may be exactly what we were looking for, because that is this number. See it? That's that negative 2. We were wondering where it's going to pop up in the formula. So if you haven't figured it out already, it's the first fraction, right? It's the first fraction. I'll show you again in a second. Plus or minus. And let's simplify this radical here, okay? So just like before, negative 4 squared is 16. And this is negative 4 times negative 1 times negative 2, right? So negative, negative, negative means negative, because negative times negative is positive. Positive times negative is negative. And it's 4 times 1, which is 4 times 2, which is 8. So this is minus 8. All divided by 2 times negative 1, which is negative 2. Okay? We don't need this here, so let me just erase this. So what does that equal? That equals negative 2 plus or minus the square root of 8 over negative 2. Now, the square root of 8, I don't want to do it over there. I want to maybe put it down here. So the square root of 8, of course, breaks into a perfect square, square root of 4 and 2, which is equal to 2 radical 2. Okay? So we're just going to simplify this. This is going to be, actually I'll bring it over here. So x equals negative 2 plus or minus 2 radical 2 over negative 2. and this reduces, okay? To 1 over 1. Okay, something really strange is going to happen here. See, what's going to happen here, it's a little magic, but it's really not. We're going to get plus a negative number. That's going to be negative. And then we're going to get minus a negative number. That's a double negative, which is going to be positive. So in a sense, we kind of ignore this. It's not that it's not being used, but we're still, no matter what I do, I'm going to get a positive and a negative version of this fraction, no matter what I do. Which one comes first doesn't matter. So it's really plus negative is going to be negative, and then negative negative is going to be positive. So I'm going to get a plus square root of 2 and a minus square root of 2. I'm going to get a plus square root of 2 and a minus square root of 2, no matter what you do. So really this comes down to, and I'm going to leave the purple though, it's going to be negative 2 plus or minus the square root of 2. So we kind of ignore that negative. We don't really ignore it, but it just doesn't matter because this says basically I need two signs of whatever you have here. So one's going to be positive, one's going to be negative. Now, when we break it into 2, right, it's going to look like this. It's going to look like x equals negative 2 plus square root of 2. And the square root of 2 is about 1.41. And we're going to get, or x equals negative 2 minus square root of 2. And again, that means left. So this is right and left. Okay, so let's see what that looks like in the graph. Okay, and let me use green highlighter for that. Okay, so it says start at negative 2. So there's negative 2 where we're going to start. Notice that's also the x value of the AOS and the x value of the vertex. See? Go to the right. That plus means right. So go to the right 1.4. So about 1.5. 1 and a little short of a half, 1.4. There it is. That's the x value of the x-intercept. That's the x-intercept physically, and that's the x value of the x-intercept. We call them the zeros. Or x is start at negative 2 and go left 1.4. So start at negative 2 and go left 1.4. So we went right 1.4. Now we're going to go left 1.4, which is a little shy of 1.5. And that's pretty close on the graph there, as you can see. So again, we went 1.4. It's actually 1.41 if you're being fancy, but we're just rounding to the 10th place. For graphing purposes, that's fine. So we start at negative 2 and we go 1.4 to the right, and then we go 1.4 to the left. That's what plus or minus radical 2 means here, right? Negative 2 plus 1.4. If you don't trust me, put radical 2 in your calculator. And negative 2 minus 1.4. Okay? So I hope now when I say what I'm about to say, right, which I think is going to be really, really, really obvious for everybody, I hope so, is going to be this. This number here, right? This number where we got from this, right? See it? From this, right? All of those, the first part of the fraction, which is from where? It's from here. It's from here. It's the first part of the fraction. That alone, the 1 in this problem, and let's go down to the other problem and use green, right? In this problem, it was not 1. It was what? Negative 2. See the negative 2? That was 1. This is negative 2. And what did we get? We got a negative 2 here. We got a negative 2 here. We got a negative 2. We got a negative 2. Where did this negative 2, all of this come from, right? It came from right here. See? The first part of the quadratic formula. So every time you use the quadratic formula, basically you're getting a number here, and then you're doing plus minus. So you're starting off at a center line. You're going plus this much to the right, this much to the right, and then we're going minus, so that much to the left. So we go to the right and left, as you saw in both of these graphs, to the right and left. So the center line is always the first number, and that first number comes from the beginning of the quadratic formula. Okay? So to answer the question, how do we find the vertex and the AOS when we use the quadratic formula? It's very simple. We take minus b over 2a, just the beginning of the quadratic formula, not the plus and minus, right? I'm going to call this the left and right, even though that's not official, but the left and right. Because sometimes it's 0, right, which means we don't go anywhere. And sometimes it's, as we're going to find out soon, it doesn't exist, or it's not real, we call it. So, but in these problems, when there's two x-intercepts, we call it the left and right, the plus and minus, the left and right. So we had, this is the center. That's the center. where we start, and then we go right and left of that center. And the center is always the axis of symmetry, and it's always the x value of the vertex. So if you do just the yellow part, that gives you this number here, which is the x value of the vertex. Of course, to get the y value, you plug in the x value into the original equation to find the y value. We've talked about that many times from the other unit, right? And then the AOS is the same x value. Just put the x value from step 1 in here. So in the first problem we did, we had -1. When we plugged all that in, we had -1 plus or minus something. And so those two numbers are -1. And of course, you know how to find this. You just plug in -1. In the other problem, the second problem we just did, if you remember, I'll go back to it, right? It was -2. We got -2 from all of our quadratic formula work here in the beginning, all these greens. So in that problem, right, we would put -2 in here, plug -2 back to the original equation, right, original function, and then find the y value. So I don't know what it is off the top of my head. Of course, if I look back here, I know it's 2. But you'd plug it in for any problem, and then you put that number also here, not the y, but the x value. That x value goes there too. Okay, so it's actually pretty easy. It's just this yellow. And now you know why it works that way. So that answers that question, and you'll have some homework problems tonight to try. And then let's answer the other question. Well, actually, no. So this problem I want you to do. So pause the video. Do this problem exactly the way we did it. See if you can figure out what the vertex is as well as the x-intercepts. The x-intercepts are going to be decimals, remember. So leave them in radical form. And then if you want to put the decimal in your calculator, that's okay. But the key, the real thing here, I want you to find the vertex and the AOS. That's the most important. And then, of course, find the rest of the stuff by plugging these three. And this is, by the way, a typo here. So fix this really quick, or it'll be fixed on yours. But -8 and C is +3. Okay, so you're going to plug 2, 8, and +3. You'll see that on your sheet. Sorry, -8. -8. So you're going to plug in 2, -8, and 3 for A, B, and C. So pause the video, do that now, and then I'll go over that. Okay, so real quick, x equals minus b over 2a, a is 2, plus or minus the square root of b squared minus 4ac, all over 2a. Okay, so let's see right away what's going to happen, right? I'm really curious to answer the main question here about this, right? As soon as the highlighter comes up, okay, about this. This is where we get the AOS. So if I do just this part, I'm going to be able to answer these two questions right off the bat. So -8 is +8. 2 times 2 is 4. +8 divided by 4 is 2. So that's it, right? So I already know, without going any further, the vertex is 2 comma something, which we could figure out. And the AOS, the axis symmetry equation, is x equals 2. Boom, right from this. Okay? Now if I want to find the y value here, I'm going to plug 2 back in here. So I'm going to get 4 times 2 is 8. 8 minus 16 is -8. -8 plus 3 is -5. So it's going to be -5. You can go slower. I went really quick there because I'm just showing you the answer. Hopefully you've already done it. And you can pause the video. Make sure you can get that same answer. Okay, then we need to do the rest of this to find the x-intercepts. Of course, the y-intercept is easy. We just steal this, right? The y-intercept is just 0, 3, right? And then we can always get another point from the sketch, right? Okay, so 64, so this is plus or minus the square root of 64. Okay, and then 3 times 2 is 6. 6 times 4 is -24. All over 4. Okay, so that's pretty easy. That's 40. So this is going to be the square root of 40. So it's going to be equal to, let's get rid of this extra. Don't need that extra there. It's going to be equal to 2 plus or minus the square root of 40 over 4. Now, square root of 40 is square root of 40. Breaks down to the square root of 10. Oops, I meant to put the perfect square first. So square root of 4 times square root of 10, which is 2 square root of 10. So right down here, we'll just put x equals 2 plus or minus 2 square root of 10 over 4. And we're going to reduce the 2 and the 4 to be 1 and 2. We're going to drop the 1 because you don't usually have a 1 there, okay? So my two answers are x equals 2 plus the square root of 10 over 2, and x equals 2 minus the square root of 10 over 2. Okay, and then that's our zeros, and of course the x-intercept is whatever that decimal is and 0, right? Or whatever that decimal is and 0. Okay, so I'm going to let you put this in the calculator. I'm going to let you find the x values here and then put it in Desmos, right? Check this in Desmos. Just put that in Desmos. You can hover over the point like we've done many times and see what the decimal is. Of course, put it in your calculator and plug it in and check it out yourselves, and then find the other point and sketch it. Okay? So I'm going to leave that to you just because I don't want to have the video run on and on and on, but it's easy to check in Desmos. Okay? All right, so we didn't answer that other question. Let's create a parabola that doesn't hit the x-axis in Desmos, right? So I'm going to pause the video, and then I want you to pause the video. I want you to go to Desmos, pick a function, just make up stuff. Just make up stuff. Put in 2x squared minus 4x plus 8 for like I did before, and then start changing the numbers, okay? So I want to see everybody's be different. In fact, maybe in the homework problem, on the homework sheet, what you could do is put this in the homework sheet as an extra problem, okay? So let's see what happens when you put this in. So I'm going to pause the video. I want you to do that. Put it in Notability somewhere, okay? Everybody's will be different, but we're going to get the same thing happening. So pause the video, make up a function, and remember on Desmos, you want to make up a function that does what? That does either like this or maybe like this, but it doesn't touch the x-axis, okay? Go ahead and do that. When you're done, finding out what that function is, do everything we did before. Plug it in the quadratic formula, see what we get for x. Okay, so here's the one I came up with. I know that you came up with a different one. Now, I'm going to say something here to help you. It's going to sound like criticism, but I want to help you. Okay, particularly when you going to college and you're on your own and there's nobody like me or your parents telling you what to do because we care about you and we want you to succeed, okay? If you have nothing here in your notes and you did not pause the video and you just let the video run because you wanted to get through this and get done with it, which I understand, I was a teenager once. But if you did that, I'm telling you, you're going to struggle, right? And when you ask yourself, why do I consistently struggle on quizzes? That is the reason why you're struggling on quizzes, because you're taking shortcuts. Learning anything is difficult, and math is no different. And you have to do it. Math is a little different in that history, maybe you can just listen to a lecture, but math, you actually have to do it. Like learning a musical instrument, like playing guitar. You have to do it. And if you don't do the things that I ask you to do, like pause the video, come up with your own function, fill this in, and then watch what I do, you're not going to learn as much because you're not doing it. You're just listening, and you're not going to learn a lot more of that. You're going to learn a lot less from listening rather than doing. So if you'd like to pause the video and try it again, go ahead. Okay. So let's put this one in the quadratic formula. It doesn't matter that yours is different because the same thing's going to happen. So I want you to watch what happens. As long as your parabola, missed the x-axis. In other words, as long as your parabola was above it like this, or maybe down here below it, whatever happened, as long as it didn't touch the x-axis anywhere, you're going to get the same thing happening even though the numbers are going to be different. All right, so my A is 1 here, my B is 2, and my C is 2. Okay, and in the formula, we're going to get x equals, right, minus B over 2A plus or minus the square root, and I'm actually going to stop in a second. You'll see why. 2 squared minus 4AC, make sure this comes over the top, all over 2A. Okay, I'm not even going to bother with this, even though, by the way, that would tell me that the AOS would be -1, by the way. The AOS would be -1, so if you want to check that, yours will be different, right? Yours will be different. You picked a different one, so you probably won't have an AOS of -1, but just FYI, remember from our last lesson, that does tell us the X value of the vertex and the AOS. What I'm really curious about is right here. This is the only part I really care about in this particular problem. Of course, in every problem you do, you want to do the whole thing, even in a problem like this, and see what happens. And I hope you did that. But I just want to focus on this part because once we see what happens here, we actually don't have to go any further, okay? So what happens here, let me use the green because it seemed to want to go green, is really, really important. So I'm going to do just the green part first. Normally you wouldn't do that. You would do what we always do, you do the whole problem, right? But I'm just going to bring the plus minus here. I'm going to put the square root. I'm going to ignore the rest of the problem just to hyper focus on this. But of course, normally we would put x equals, we would do this, and do all the work. But look at this. This is going to be 4. This is negative 4 times 1 times 2 is negative 8. Okay, 4 minus 8. Now, you can go ahead and do the rest of this. You can do the bottom over here, which is 2. But when we go to try to take the square root of this, what's going to happen, right? What's going to happen is not good, right? This is not good. It's not red, but I'm trying to make it like a warning, right? 4 minus 8 is negative 4. Guess what? The square root of negative 4 does not exist. Does not exist, right? It's undefined. You can't find two numbers that are identical that multiply to negative 4, right? Negative 2 times negative 2 doesn't work. That's equal to positive 4. And 2 times 2 doesn't work. That's also equal to positive 4. There is no two identical numbers, including the sign, that when you multiply them together equal negative 4. So when this happens, the entire answer to x is d and e. You don't have to go any further. So it's actually kind of a cool thing to check right away, is to do this right away. So x equal, this is not a 0. This was just that work, right? So if you do that work, which is, it's not so hard to do. It's just negative 1. Right? So negative 1 plus or minus the square root of 4 minus 8 over 2. 4 minus 8 is negative 4. D and E. D and E. And why is it D and E? Well, because you're asking the formula to tell you what is the x value where this parabola hits the x-axis, and it doesn't hit the x-axis. That's the whole point. That's what we went to Desmos to play around with and to try to come up with a parabola that does not hit the x-axis. We did, and no matter what it is, now your numbers will be different here. But this purple part underneath the square root, you're going to have a negative number just like I did. Okay, so we answered the question. When we create a parabola that does not hit the x-axis, what happens when you try to find the x-axis in the quadratic formula? And of course, the answer will come out to be d and e because you cannot have a negative square root. Okay, work on the homework sheet. I will provide you feedback like I did before. You may have to redo the problems again. Look for my feedback. Good luck.